All right, so here is the How Many Significant Figures worksheet located in Math and Measurement, and I'm going to do probably 4 examples here of counting the number of significant figures based on the rules that we have already learned. So let's look at number 2. Number 2, the value is 1.498. Now, we should know that any non-zero digit before or after the decimal is always going to be considered significant. Therefore, since we have 1, 2, 3, 4 non-zero digits in this number, the number of significant figures is 4. You may see me use SF. All right, let's look at 16. 14.380. Well, we know that any non-zero digit is going to be considered significant. In the case of this number, we have a 0, so how do we deal with it? Well, the rules for zeros say that zeros that come after a decimal that are after a non-zero digit are considered significant. So therefore, we have 1, 2, 3, 4, 5 significant figures in this value. All right, let's look at number 20. 4,500. 4,500 has 2 non-zero digits and 2 digits that are 0. Since there are no decimals involved and these zeros are what we call trailing zeros, they are after non-zero digits, then these zeros are not considered significant. Therefore, this number only has 2 significant figures. Let's look at 17. 307. 307 is a number that has a sandwich 0, and remember, a 0 sandwich between 2 non-zero digits is always significant. Therefore, this has 3 significant figures. Moving along to the math review worksheet, here's some calculations. And remember, we've talked about how to do just the regular operations. Now we want to talk about how to do these operations and report the correct number of significant figures. So let's look at a question like number 6. Number 6 wants us to add 12.15 milliliters plus 3.7 milliliters. Well, once we add these together, we get 15.85 milliliters. But knowing the rules for significant figures for addition, we know that when it's addition and we have decimals, it's the least amount of places after the decimal. This value has 1 place after the decimal. This value has 2. Therefore, our answer should only have 1 place after the decimal. I normally like to underline wherever that is in our value, and then looking to the right of that, immediately to the right, this value is what dictates whether we round up or down. Since this value is 5 or larger, we are going to round up. Therefore, properly reporting this value should be 15.9 because we have rounded up. All right. Now let's look at number 7. Number 7 is the operation of division. We have 8,877 centimeters cubed divided by 610 centimeters. Now, you're going to have to do some computation here in the calculator. So, bring out your calculator. Go 8,877 divided by 610 in the calculator. That's going to give you 14.55245902. All right. The rule for division states that the number with the value in the operation, with the lowest number of significant figures is what dictates your answer's number of significant figures. This value has only 2 significant figures. Remember, trailing zeros are not significant if there is no decimal. And in this value, there are 4 significant figures. So the lowest number of significant figures dictate how you round. So the second significant figure from the left in this number, and this should actually be centimeters cubed. This should be centimeters squared because we have lost 1 centimeter. We have divided and canceled 1 out. Therefore, we need to look to the value to the right of that. Therefore, our answer to this should be 15 centimeters squared. We canceled out 1 of the centimeters because we used 1 up that was in the denominator. And then we rounded based on the 2 significant figures in the smallest number. Okay, let's look at the Sig-Fig measurement conversion review. And number 3. So on this worksheet, they want to report the proper number of significant figures for a multifunctional operation. This is very important that you know how to handle these types of problems. We're going to separate it out. So the operation is 6.404 times 2.91, and all of that divided by 18.7 minus 17.1. The first thing that you should do is you should do each operation separately and save all of the digits associated with each operation. So 6.404 times 2.91. That gives us 18.63564 divided by 18.7 minus 17.1 gives us 1.6. Each of these operations was different. We have a multiplication and a subtraction. The multiplication, let's deal with first. We do not want to round a multifunctional problem until we are at the very end of the operations. You do not want to round this value 18.63564. What you do want to do is you do want to establish the amount of significance that this number has that was carried from the original operation. We have 4 sig figs here. We have 3 sig figs here. By now, if you cannot look and immediately determine the number of significant figures in a number measurement, you need some more practice. 3 significant figures is the least, since this is multiplication. 3 significant figures is how much significance is carried on to the next number. Therefore, underline the 3rd significant figure in that problem. That does not mean that you need to round right now. It just helps you understand and placehold so that you know that you're working with 3 significant figures here, although you've kept all the rest of these numbers. Now let's look over here in the denominator. We have a subtraction. This subtraction, remember, significant figures is based on how many places to the right of the decimal. We only have 1 to the right in each of these. Therefore, we should only have 1 to the right in this one. So our last significant digit is here for the denominator. You want to keep all of these values together when you subtract. So you should have 63564 divided by 1.6. This is going to equal 11.647275. This is not the correct answer because you have not reported it to the correct number of significant figures. In our last operation, based on order of operation, the last operation is division. That operation says that the lowest number of significant figures is what you should use to report. Therefore, the second significant figure in this value is the 1. We need to look to directly to the right of that for our rounding purposes, and our correct answer for this problem is 12.